My name's Adi. I'm going to be our host moderator for this evening. I would like to quickly introduce our panel, or I would introduce ourselves. So I see, would you like to go first?
Yeah, there you are. Hello, everybody. My name is Alexey Kravarov. I'm the head of community at a company called Lake Sail. We're a recent young startup. We rebuilt the whole Apache Spark ecosystem in Rust, including Iceberg, Delta Lake, catalogs. And I started 15 years ago. The very first Apache Spark meetup, I found Matei Zacharia. He was a graduate student at Berkeley. I was an early adopter of Spark at a startup called Cloud. I set up like the 4-node cluster. The timeouts were wrong, so I asked him to help me. I met him in a cafe shop like in midnight, and he presented Scala, my meetup, the biggest Scala meetup in the world, and we started together the first meetup for Spark. And so 15 years later, I launched PySpark client, and the ASCII logo of Spark comes up, and there is no JVM. All right, this is the magic. We're in AI and Rust era. I believe that Rust is the foundation of AI, personally, but we need kind of semantic layer. We need ontologies and everything. And I'm super excited to be with these folks because data, I think it's a foundation of AI. It's a kind of the secret, the elephant in the room. None of the AI makes any sense unless you get your data right. And all this agentic activity will not succeed unless you have the last mile customer AI corporate data, which is black box, which is not, on the internet. Claude and Codex know nothing about it. You need to figure it out. How do you link it up? And so I'm really thrilled to be with these illustrious folks who work with this data kind of close to the customer. And let's figure it out. How do we do the last mile?
It's tough to follow Alexey. I'm Andrew Madsen. I'm head of developer relations at Fivetran, now also DBT, joined by acquisition of Tobiko Data. For that, I was the chief data officer at Dremio. Shout out Dremio for their acquisition. Congrats to them. And before that, I had a real job where I led data and machine learning at a bunch of different places.
Microphones and all
That's right.
You're very popular.
Hello, everyone. Thanks for being here. My name is Mark, and I'm from a company called Datastrato, which is the provider of an open source catalog called Gravitino. We live down at the bottom of your data stack, down where your data files reside, because we help people set up Iceberg catalogs. So if any of you are setting up or currently experimenting with Iceberg tables, we will provide you an Iceberg catalog that's open source, which means it provides all of its great features as part of an Apache governed open source. And then we integrate additional data sources. Very few people have Iceberg alone, which means that in addition to your Iceberg data lake, you've got some Postgres, some Oracle, some Hive, some this and that, and we unify it all so that your agents have a consistent data plane to get access to all your great data. We provide a semantic view on top of it, and I'm excited to tell you about that.
Hi, everybody. My name is Josh Wall, and I'm the principal architect at LiveRamp. So LiveRamp is a identity provider and also a data collaboration platform. I'm specifically working for the data collaboration platform where two companies can collaborate and run analysis on the data without sharing the raw data. And in the past, I've been working in the MarTech industry for a long time, dealing with large volume of data, and use a lot of products those gentlemen has mentioned. And I'm glad to be here.
So our first question is actually for the audience. Show of hands, who's running an agent in production right now? Are they touching production data? Cool. Just curious. Josh, at LiveRamp, you built a semantic layer that allowed your agents to be able to gain a sense of the data sitting across a dozen different systems. What drove that decision? Were they going rogue, or like what was causing you?
Why would we build an agent to go across dozens of data platforms?
Specifically the semantic layer that you built.
In the industry where if you're building a platform data collaboration, usually the setup of kind of the access control, the policy around data usage is super, super complicated. And we are really looking at policy at row level and column level, right? And that kind of multiply across different data catalog, different data sources. So one of the reasons we want to go to agentic kind of workflow is because the complexity. So in this new agentic era, complexity is actually your friend now, because agents can navigate a workflow much easier without a constraint of your UI, right? And they can go to different systems and do federation a lot faster or swift than a human being. So that's why we kind of start to look at an agentic workflow. So we have building basically tools to allow our partners and customers to build their own agentic solutions by exposing MCP servers as well as a semantic layer to guide the agent to better understand the data and also kind of issue the correct SQLs or questions and analyze the data.
Yeah. I think one of the first questions developers ask themselves when we're working with this is, how is this any different than any of the other programs that are before? Why are our ACLs as they stand today insufficient? Right. And so there's a question to the broader as well. Like, what are y'all's thoughts on that?
This one.
Yeah. Well, I'm a provider of a catalog that has ACLs within it. And speaking to that question, I would say that there's a huge difference when you come to agentic workflows, because if you're going to create a script, you know exactly in advance, statically, what tables your script needs to access. If you're going to create a service account, which we have done for many folks who want an OAuth token to have access to a service account, you know in advance exactly what that thing is going to do. In the agentic case, you do not know. That's the big difference. And the degree to which you do not know, and the agent is going to dynamically determine what it's going to access, is what you have to ask yourself in terms of the privileges and permissions and protections that you need for the catalog to provide. There are a whole variety of potential techniques. Typically, a catalog will provide a multiple number of roles. And so one technique that some people find sufficient is that they will have a role narrowing sort of function that will force the agent to choose one role or another. That way, if the agent is doing many things, they don't have access through role A to all the stuff that they had in role B, because that kind of cross correlation is a problem. Or you have task-based allocations so that the catalog is being asked to control through a static list the number of things that the agent can do. But without getting into specific solutions, I would say that the big difference is the degree of dynamic determination of what the thing is going to do, which is the big difference.
Let's see, Henry, you're not very hesitant. So anything you want?
No, I'm completely aligned with Mark. Yeah, it's perfect. I couldn't have said it better.
So I want to add a wrinkle on this. So I'm participating in this group from AI Alliance, which is an organization set up by IBM. So I was one of the co-founders. So it's IBM, Meta, and 200 other companies, a bunch of government organizations. So they come to kind of data world from agentic viewpoint. So they're not big data people like most people here, right? So like not like houses. And so and I think some other organizations, Mitch Tsuda is here from the government of Japan, right, building open data spaces. So the idea of that, and so we have an initiative called Semantic Corresponding Query Graph. So there are several standards which came, from different worlds, kind of agentic, and they start with ontologies, right? And the question is like, if you think of agents as primary entities, they need to operate on ontologies. Let's say you have an automotive data set, right? So the example is, so let's say you have a Mercedes, you're in Germany, something breaks. It's a smart car. It signals to a Bosch service station that it needs some part replaced. It schedules an appointment with that Bosch service station, and the Bosch service station is to check with its supplier, which eventually has a supplier in Shenzhen, which makes the part. And so all the parts in that example should have exactly the same name in the ontology. So the ontology should not be controlled by any database provider is a domain-specific, industry-defined ontology. So the ontology should be governed by Bosch and shared by Mercedes and the Shenzhen provider. So the agent basically, in this case, needs to align on the ontology and then basically do whatever it needs. So folks who basically come from that background, so they need to foster, right? Like the EU governments are very big into interoperability. So we have kind of big business here doing this, but in Europe and in Japan, they have governments who take charge. So they basically say, let's create a common shared space. The ontologies in different industries will be owned by consortia of the industries, like automotive people will come together. They will define different parts, right, which are parts of the car. And like you cannot be Databricks or Snowflake to say what the part of a car means. It should be Audi, it should be Porsche, right? It should be a car, it should be Toyota. And so as a data provider, as a database, you need to figure out, but you are, let's say Toyota or Bosch, they have the lakehouse which stores all of the data. So you need to consult the ontology provider and figure out kind of what part means, and then enact a series of actions. So these people actually, because they do not come from the big data world of catalogs, they lean on semantic web standards of 20 years ago. So they use something called ODRL, which is a policy control language predating things like RBAC or ACL. And so, but it's extremely fine-grained policy control language. So you can basically say for any table, for any piece of data, these are the people, you define policies in general. And so it used to be extremely hard and unwieldy. So we kind of used to think that semantic web is obsolete. This is a kind of, a bunch of scientists in Germany kind of who keep doing it. Doing RDF, nobody told them this is not needed anymore. What happened is ODRL is extremely complex for humans, but it's extremely easy for agents. So you can actually have agents write elaborate policies to cell level in a table, right? So I'm actually very excited about this. What I would like to do personally, working with folks here, is to bridge these two worlds, right? So we have two tracks. We have kind of government agencies and data scientists working on kind of policy-driven data governance things in Europe and Japan, and we have business-driven bottom-up things in the US. So people like very kind of practical, like let's define the business metric as a SQL query, which seems like a very like low-level pedestrian ambition. Like it's not big vision now, but I just was at Snowflake Summit, and Snowflake people actually just added ontologies to their open semantic interchange, and so they actually have ambitions because you can now put ontologies in the catalog. And so I'm super excited, Mark. Like you are in the OSI group. I just learned about this, but you know much more about it. So I'll ask you to follow up on that because I just learned about it today.
I don't know that I have much to add on that question, actually. So let's go on.
Kind of jump to what I was going to talk about next. So I'll get into the question I was going to ask after that is how do you test all these things actually work? And then when they don't work, how do you debug them?
I can go a little bit. How do we test it's actually working? So one of the biggest difference when you build an agent versus building a scripts or building a software is can you guys hear me okay?
Mm-hmm.
Okay. So one of the biggest difference between building agents and building software is I would think so basically when you deal with data analysts, so it's a human, but a human has institution knowledge. So they know what's right and what's wrong. But a human is also not very predictable. So they can be wrong sometimes also, right? But they have the knowledge. When you build an agent, it's more, it has some attribute of scripts. It is writing code to analyze your data. However, it has some attributes of the human also. It's non-deterministic. So testing become very hard, but also very important. So in our system, we do have a set of evals that will have the agentic CI/CD to evaluate when there's a data change or there's a shift in the schema, or we just update our using a different LLM model. However, testing is still very, very hard problem. I think we are still very early in this agentic era. It's the character is non-deterministic. A unit test does not apply to a eval in the agentic world because it's non-deterministic nature. So we still require lots of human kind of stewardship to evaluate, and have a expert. Our data analyst will evaluate the results, and before we go to the production. That's our
It's around there. How do you all remember that?
Yeah. So one of the debugging, which one? Thank you for the question, which is very, very important. So for building agentic, it's very, very important to have traceability of what agent is doing. And what does that mean is not just having logging on the actions, but to pass through identity from the beginning all the way through the backend using who is the agent operate on behalf of it. So basically, as we said about service accounts, we probably don't want to use service account because your audit log is not going to tell you anything. It just say agent did something, right? It's an event log. It's not an audit log. But identity itself is really, really important. So agent must be operating on behalf of the user, and that traceability needs to go through all the way up. So that's kind of how we do it.
So to throw it over to Andrew, how do you prepare the data to make this the most viable system? I know you wrote the book on this.
It really depends on the use case, to be honest. Jensen Huang just recently said that structured data is the foundation for trustworthy AI. But what does that structure look like? And it really depends on the use case. It can be semi-structured for a lot of cases. Sometimes it really needs to have that semantic layer and that strict ontology across systems. It depends what the end use case is. And the joke is that we need a semantic layer to control all of our other semantic layers, which is why the open semantic interchange exists. And Fivetran just open sourced agent schema, which the DBT semantic layer and the open semantic interchange all roll in, and then we store that in the database, machine readable, so that then no matter where your data is, your agent can go find it, read the schema tables, and then go and get it. So it's really organizing your data in a structured way that's both machine readable but also traceable. And what that looks like a lot of times with the agents I'm seeing in production are consolidating a vast amount of your data into something that's open, something like Apache Iceberg, Delta Lake, and then exploring with the things that do need embeddings, put those into a vector database. And then, of course, you need OLTP. So then you've got kind of this three-pronged approach of your OLAP, but it's open, it's in Iceberg, something like that, OLTP vector, and then you need a query router. I'm seeing that work really well. So I'd like to learn more from LiveRamp about the tracing, because I am using event-based tracing. He's like, don't do that. I'm like, oh, crap. I'm doing that in production. So, but in terms of structure, it's like, is there meaning behind it? And can you trace it? And can you find it?
Access and getting to that single plane of awareness is often really difficult because you're getting all these different business units with different rules and such like that. So this question I'm going to throw to Mark initially, but I have a feeling Alexi, because you already started to talk about this some year ago and nothing as well. How do you manage to get all of those distress systems together and create a single unified semantic layer? To Andrew's point, do we need a semantic layer on top of the semantic layer on top of the semantic? Is it turtles all the way down?
So I'm a community guy, right? We have a lot of, who's in the community? Who's DevRel here? Who's doing DevRel? Anybody? Who's doing open source? Who's a coder? Don't be afraid, don't be shy. So in my mind, right, we do not have a single system to solve all of this. People try. So there are modern, new agentic database like HelixDB, for instance, came up with a new language, a SQL with graph primitives, and SurrealDB has others. So people are basically, there is a one school of thought that let's have a new system for agents, not for humans, which will enable agentic workflow. So Surreal and Helix want to do that. But, the query languages are new and modern, newfangled. Claude and Codex don't know how to do them because there is no training corpus, right? So I think I just came back from Snowflake Summit. There is a company, you will never guess who uses data. They're in St. Louis. They're called Grimco. They are sign supplies company. So if you see a sign here, in your size is open. There is a company which makes signs, right? Like a frame and a glass and a sign. And Grimco is a supplier of these companies, right? all around the country, all around the world, people make science. Grimkins and Lewis make supplies. There is a stock table, right? Like, and they just migrated to Snowflake from SQL Server. So this is the reality. We live in a bubble here, right? Like, lots of people use SQL Server. Like, step outside of San Francisco, there is a mishmash of legacy stacks. They're not going away, not replaced by HelixDB. So what needs to happen? We need to basically, as open source community, we need to put together reference open source AI implementations, which all of these folks can take, right? So, and as kind of as vendors, as technology leaders, a lot of folks here are open source first. I don't even know if anybody here is closed source, open core, mobile. So, as Andrew said, like you have RAG, right? For vector queries, you can use Quadrant, you can use Turbo Puffer. If you believe this is the answer, you need vector search. Use Turbo Puffer. It's cheap, it's effective, it's used by everybody. You can use it from command line. Tip off your command, your agent can use it. If you want a lakehouse, use Lake Sail. Use Sail. Sail is fast, right? Like replaces Databricks out of the box. So, like, if your lakehouse, if your catalog, use Gravitino. So pick an open source tool, and then basically build a stack out of it which answers your question. And so that's kind of my approach to how. And so each of the systems is good at kind of doing one. And it also depends on your kind of data, right? So different companies have different workflows. For some, you need vector search. For some, you need the SQL query in a lakehouse. For some, you need unstructured search. So like you have a bunch of PDFs, you have some dark data, you need some workflows. So I think it will be bespoke, tailored to your specific workflow. And workflow people are much harder to change. We can iterate here every week, right? Like I just came from OpenClaw meetup. There is a guy there who is second to Pete. He consumes 15 billion tokens a day, right? So OpenAI is paying $1 million a day for this guy to run his stuff. It's mind-boggling. So like Grimco in St. Louis is not going to be that, right? They have a reliable business. They have their lake house. They just migrate to Snowflake. It's a proof of concept from SQL servers. They have a bunch of things. They're going to add different things. So like they can evolve, right? They have people who live in St. Louis. They're not going to move to San Francisco. So like you need to basically take this as a foundation of reality. And you need to figure out how do we reach out to these people? How do we, like the easiest way is to give them an open source reference implementation stack. So I call on everybody here, let's all get together, let's make a bunch of open source reference stacks and give it to people and they can pick what they want, right? That's kind of my approach. The ecosystem, the open source is the answer and rising tide lifts all the boats. Like everybody here will benefit if we figure out how to solve real world problems with specific tools, right? And like the fast and best tool will win in each category. That's kind of my recommendation.
All right, anything on the answer?
Well, Adi, I'll give you that back.
Okay.
And I'll use this one. It seems to, yeah. The one piece of advice that I would share is that I think that most AI use cases can be divided between one of two use cases. The first is access to governed metrics because your AI agent is doing some kind of an analytic use case, in which case everything that we've seen at the Snowflake show or everything you've seen before today about semantic layers and the interoperability of semantic layers in business catalogs is going to be fundamentally important. On the other hand, there are huge classifications of AI agents that don't go anywhere near analytic use cases. If you're doing business process reengineering, you're probably starting from a need for object access. You need to look up a row in a table in order to get a customer record, or you need to chunk a PDF in order to read some kind of unstructured data or an audio file or a video file. And in all these other later cases, a semantic layer is going to do you significantly less good. Let's just say that. And so there you have the two halves of the way most of my customers think about how to segregate their AI workloads. And I think that will potentially help you to go from there and thinking about, well, how do I need to structure what's underneath? Now, on the first side, if your workload is doing analytic type queries in which you need to determine what revenue was for this month and compare it to revenue last month, then you need a dependable way to compute that. And that's what the semantic layer is meant to do. You don't have to deal with a view that has SQL underneath it or tables in which you have to aggregate a column or any of that jazz. That's not a governed metric. And so the semantic layer is meant to define what revenue per quarter means, and then you don't you just choose that and boom, it appears. But that's great for, again, as I say, an analytic workload. If, on the other hand, you're doing the other side, then you're going to want to think about, how do I get whole access to objects? What are the access patterns that I need in order to do customer lookup records? And on from there. Hopefully that classification, Josh, fits what makes sense to you.
Yeah, absolutely. I actually want to double click on that. I think it's very helpful to have a data catalog, especially if you're using open source. It's just because LLM is better trained with open knowledge, right? But to double click on what semantic mean is actually going beyond the catalog. So what we learned is our first version of the agent point to the tables, and works perfectly when we ask the agent to write a SQL and interpret business meaning. It works perfectly in demo. Because when you actually give to the user, the data analyst, it immediately fails, because when a SQL is 80% correct, it's 100% wrong for the business. So just like Mark said, like what does revenue means? It can be very different formula in different departments, right? So how they put a where clause, how they segment, how they partition the data, how they consider month over month versus year over year, how to define a period is very different. So these things you cannot leave to agents without context. And that's actually the semantic layer we're talking about, that is on top of the data catalog and beneath the BI, right? So this is the middle layer. I think that's very new for the agentic world, where currently most company probably is still combine BI with the semantic layer to serve visualization or serve the analytics analyst. What is also very important is when you start to access those data, how do you go around your company with your security team saying, hey, I can have my agent query this now. And the most practical approach that I found, at least, is you start with a trust data already, right? You start with your current BI layer, because your current BI layer probably already have trust formula to calculate revenue, right? Your current BI layer probably already have user-based authentication and access control to your current BI system. So you start with there, let agents assume the role of that user, so that you don't go through open a new access path to your data. So that's why the semantic layer and the user identity is super, super important when you build a real world application.
Josh brings up a really great point, and this came to mind as Mark was talking, is even if you can nail the BI layer and you've got a semantic layer, now we've got a new challenge of the volume. Right? I mean, a lot of companies, as we say, we're in a bubble here, and a lot of companies all over the world struggle with just managing the volume of the Power BI and Tableau and Omni queries. And now we've got agents spawning sub-agents just hammering your systems. So monitoring the access patterns, the query patterns, and determining and making a call of what do we cache, what do we materialize, and how do we do that in a meaningful way? Now it's not real time. Is it near real time? What are we going to do so we don't crash the system? That's a real challenge that companies are struggling with, and it's kicked off a ton of new startups figuring out how do we create a caching layer between agents and our data.
I think I'm finding cache. So in the backdrop of Snowflake Summit, I think price, tokens, and everything else on all of this is top of people's mind. How is what you all are talking about, semantic layers and things like that? How does that affect price? Does it make it higher, lower? How can it help constrain costs?
Ooh, I'll kick it off first, because then I'll be wrong, and then Mark will correct me. I mean, the less is more for alignment paper is like my Bible. Like you can have a much smaller model with way higher quality data outperform a giant model that has crappy context. So you can just run a smaller model, keep it simple, but really focus on the context, and that'll minimize the tokens. It'll improve your accuracy. And I think that's a sustainable way to go. And it also kicks the business in the butt and makes them focus on getting the context right.
So, I'll come back to this kind of idea of two worlds. So in my community, research hat, right, I work on the open source project called QueryGraph.ai, and that's similar to open data spaces by Michitsuda and, the government of Japan. So basically, what it does, it establishes these ontologies, very deep, right, and industry-based. It uses a standard called Croissant, which is the Google co-author standard for data sets. It's basically metadata for data sets for agents, right? So you have very fine-grained JSON-LD definition of every data set. And semantic Croissant, which is Croissant 1.1, takes it to ontologies. So it's a ML common standard. You can look it up. So what happens is if your agents operate in a company, what you do, you fix an ontology, and then every query you wrap in, you could use XML, you can use JSON LD, but if you wrap your query in very fine-grained XML, and so there is a proof of concept we did with Codata, which is the European agency consortium. So they hacked Olama to accept basically queries formed as, this XML packets in the standards is another W3C standard called DID, decentralized identifiers. It's a Hyperledger standard implemented by Azure and others. So imagine this: you, instead of sending plain text, instead of sending skills and prompts as markdown, you just get a DID, which is uniquely resolvable global identifier, which carries an XML payload. In the XML payload, you can have a public key, you can encrypt it. And the query is basically every entity in the query. Normally, you don't invent new things. Like if you're a company like Grimka, you have science, you have paint, you have metal, you have glass. All these things are in tables somewhere. You resolve them uniquely to IDs. So when you give it to Olama takes the DID, it unwraps it. If it has an encryption permissions, it uses a public key if it can do it. Then it gets the plain text, which is XML payload. And basically, it's a bunch of XML with terms which you already have is grounded. So what happens is you have 1 million tokens per second without GPU. You have CPU only processing server-side without touching the GPU. So we basically demonstrated in the proof of concept, we can decrease the agentic costs by 1,000x. Don't tell it to NVIDIA, right? Like basically these people say short NVIDIA because in most corporate workflows, you don't need to reinvent the wheel. You are not solving the meaning of life problem. You are solving the query, right, against the tables. Like, give me, why did my, coffee maker sales go down? Like, people in New Jersey stopped buying them in the morning. What happened? Because something's probably wrong, some tables wrong, some services down. It does not require AI, really. Like, it requires very basic model. So Olama with some open source model is sufficient. And moreover, you will do most of the processing server side. So in my mind, if we have full control over the data, we can basically see what are the patterns of customer queries. We can cache the heck out of them. They're not geniuses. They're not going to ask you elaborate questions. They ask you very predictable queries all the time. We'll query them and we'll answer them without touching the GPU. So I think that's going to be the future. Most people will just ask the same questions which were asked over and over, and then this will come tomorrow. He's not going to suddenly ask a new question. He's going to ask the same question. So I think that's what's going to happen. So basically, host your own open source model, build your own infra, and then you will run it basically at the CPU cost.
Thank you very much, guys. I want to agree with everything that was said, but I want to give you a couple of other thoughts. I've heard many people complain about the cost of tokens and this and that. And so what I would suggest for anybody who's starting an agentic project is, first of all, to know the value of the work that you're delivering. Now, here's what I mean by that. I've talked to many people in the healthcare industry who are talking about re-engineering the patient process. And I guarantee you, in 5 years, the experience that going to your doctor will not look like it does today. There will not be a nurse at the door. There won't be anybody there to take your chart. There will be a kiosk. Now, rightly or wrongly, that's what it's going to be. And so let's suppose that you're working on a process like that. You would be well served to understand what the benefit is that you're delivering, because what every healthcare provider wants is the cost saving and increased efficiency associated with that process. And so you're replacing today's process. Or I spoke to a gentleman who works in supply chain. All right. So you've got a supply chain that you're going to automate with an AI process. You're replacing the old junky system that's there now. You're going to have significantly fewer errors, significantly less human involvement, significantly whatever it is. Okay. So the first time anybody gives you any hassle about the number of tokens you're using, you understand the value because you understand the value of what's been replaced. And basically what I'm saying is that I think that anybody who wants to complain about tokens needs to first understand, wait a minute, the value of what's replaced is probably incredible compared to token cost. Now, the second thing I suggest that you focus on is the whole important point of a semantic layer is not token minimization, although it does that. It does token minimization because it now gives you the metric that you wanted without the agent going back and forth and making a bunch of errors and all that. But the real benefit is not cost savings, it's accuracy and efficiency and dependability and metrics you can trust, which all boils down to something like data quality or something like that. And so here again, I think that as developers or as people who are driving these sort of changes, you can tell the boss, the client, whoever it is, in the first place, the value of what you're attaining is unbelievably high compared to what you had. And what's really important here is that we do this with high accuracy, with high efficiency, with high quality. And that should carry the day.
Yeah, sure. I mean, you've just provided an awesome different view of thinking about a cost in terms of value. I just want to add a little bit on really just the token consumption and also the cost to your data layer, because that's also a pretty expensive layer. So I think the first thing is, if you have a deterministic workflow, I think you should still use AI to help you to build a blueprint. But when the blueprint is settled, you can turn that into software. It's still a cheaper way and a deterministic way to execute your workflow, right? If that's deterministic. But when it's undeterministic, and when you think AI can add their reasoning to it and automate a lot of things, and after you build the agent, you watch the steps, what agent's actually doing, and see if there's a waste there. And that's where the semantic need to fine tune and help the agents to do it. A real example, for example, when agents do a query, and if it does not know your dimension, the cardinality, it will accidentally execute a high cardinality for summarization. That is going to be a very costly query, right? If your semantic layer can give a profile of the data, then you can guide the agent to not do that. So lots of thinking is added to the semantic layer, not just the definition of the data, but also data shape, data profiles, and how you want the data to be used. Another example, for example, if you have a column of ratio or share of the market, you need to tell agent to not sum it, right? So agent does not need to back and forth with the human being in a conversation that do a whole bunch of random stuff that is not going to make any business sense. So yeah.
Josh brings up a good point about interoperability, because just like Lake Sail is doing lake houses, that does a number of things. You can consolidate your data, all of that, make it easier to govern, but also it gives you that interoperability for compute engines. Now suddenly you don't necessarily have to run the Databricks or the Snowflake or whomever on every single query. You can run DuckDB, you can run Trino, you can run whatever you want and match the engine to the workflow. And being able to do that through an agent is critical. So that was a good point Josh brought up, that not just inference, but also the database compute is hugely important.
So I mentioned organizations as the organizations themselves. One of the ones that I think are the sign-offs that people I think dread the most is security and security easy. Any tips for the audience on how they can get past that particular hurdle?
Yeah, I think I mentioned a little bit before. So basically, if the best approach is first start with the existing security model. So reuse what's working and what's already existing, approved by your security team. That potentially means you use the user level identity for your agents. And what is very important is the traceability, auditability, like what happened, which agent on behalf of whom is doing what. So that's time to her. And the one thing, keep in mind that the semantic layer can do a lot of guardrails, right? To guide agents what should do, what should not do, or what's the best way to do it. However, it does not reduce this risk to zero. So keep that in mind that when you are working on agents can make a mistake. And the responsibility is still the person who is using the agent. That is not going away from security perspective.
Josh makes such a good point, and I want to build on that because there are many semantic layer products that will provide you with the ability to create tags on your data. And they will pass those tags to the agent. So you indicated that this table is full of PII. And that tag went into enriched semantic information that went to the agent. Well, that's great. What did the agent do with that information? Anything from fully honor it to fully ignore it. Because anything in that vein is ignorable. And you probably know that. So as a catalog provider, one of the things that we look for are opportunities to push these security constraints down into the enforcement layer as much as possible. And to the extent that you're vulnerable, depending on what kind of data you're dealing with, maybe something that you want to think about. What we think a lot about doing is providing semantic information from the catalog up, because the catalog is the point of enforcement. And so if you're going to create a policy that your agent can't have PII and it's a high degree of exposure for you, then you want to create that policy where the point of enforcement takes place so that the agent will never see PII and is not simply told, hey, this is PII, don't do anything with this.
Yeah, one of the most successful methodologies I've seen work in production is there's an open source company that has a great pattern, Spice AI. I think it's Apache 2.0 licensed, where you can onboard agents like people using this pattern because each person can have their own instance, and that instance has all of the access controls baked into it for that person. And so then it's insanely cheap to spin up an instance for each person, and then you're not building one agent and then trying to slice and dice it for each person. And so I've seen that be super successful with giant companies like Twilio's using that. And I think they have something like, I could be wrong, but I think they have like 1,300 instances of individual agents, all with their own access controls, working at scale.
So I just want to nerd out for a minute. Who here is programming in strongly typed languages like Java, C++, Rust? So I just remembered an amazing thing from like a few years ago. So, I used to run the biggest Scala meetup in the world, and Scala is crazy about types. So there was a security company which did something very interesting. They basically modeled security as types, right? And so Scala has traits. What I love about Rust, which we chose, it also has a bunch of traits. And so you basically specify a bunch of traits to different functions as features. And so what these people did in security, they basically defined the security at compile time as traits. So if you violate security, your freaking agent won't even compile, right? Like this is the Rust philosophy. The wrong thing will just not compile. So we are a long way away from this because we have agents in Python and TypeScript, right? But because most modern AI is basically thin wrapper of Python around Rust, right? And by the way, I'm starting new Rust AI meetup, July 27th at AWS Builder Loft. So like if anybody's in Rust, please come over and give a 5-minute pitch. So Rust is a data foundation, right? So like, why are we going through contortions, translating data into Python, into Goo, which is untyped and like unsafe, and JSON, and then like serialize, deserialize, pass it around, bounce it. Like all this stuff is waste. Let's just do it in ADBC. Let's have very fast Rust-based typed bus. Let's use protos that send data which is typed, and our security can be embedded in multiple levels. Like if you're not allowed to see this data, your program to try to get to it will never compile. Your agents will not exist, right? So like if you define your agent in such a way that it has to have a Rust implementation, and your security policy does not allow you to create a Rust implementation which compiles, you will never have an agent. You will never access this data. Again, like I'm kind of very bullish on types. Types are great for Codex and Claude. They cannot produce bullshit because the code which they will hallucinate will not run. They will not even compile, right? So like, why don't we push this into that layer? Like we already push predicates into Parquet. Why are we not pushing security primitives into our lakehouse? That's my humble proposal.
So you I think kind of mentioned a good point here, which is, if we treat them like people, we kind of can co-opt some existing systems that are there to help train existing engineers and things like that. One of the things that kind of begs the question about is auditability. So how do we then, does my identity then follow that agent, or how do we then segment that out for our security teams in a safe model?
We follow a process that's, my personal background is in queries and query optimization and stuff like that. And in that world, you have an idea that you want to push down. You want to push down the query to its ultimate source, because that's where it's going to be. That's where it's going to be run most efficiently. And that principle applies in many different areas, and this is one of them. You want to be in a situation where your user identity is pushed down as far as it can be pushed. If your user identity is visible to the catalog, then the catalog is going to be able to give you an audit log of whatever user did. And that's highly valuable. So if your agent isn't using an OAuth token to present to your catalog or database, there's a very big oversight that you could correct right away. Now, if you're using a catalog, we follow the push down principle. We want to push down that user identity to the other side of the catalog, which is a database or a file source. Because again, if the storage device knows the user identity, then the storage device will keep an audit log. And for a highly secure or a highly secure sensitive team, this is gold. This is everything they want, because now you have the gold standard. You have the user identity pushed all the way through the chain to where it ultimately accessed a data element. You know that user's name, you know every detail about when they did it. And so that's what I suggest if you're in a highly secure environment that you think about.
Cool. All right. Last chance for questions from the audience. Anything y'all want to close out with?
I'll just add one more thing to auditability. Again, huge fan of open source standards. So OpenLineage.io, it's a Julien Ledam's project. It basically traces any transformation, right, and basically keeps auditable track of it. So we have standards, right? Let's just use them, and then we can keep track of what happened to your data.
Thanks, anyone.
I just want to echo what Mark just said. It's very important. I think it's really the best practice. But I also want to just add that you want almost everything when what the agent actually is doing that will potentially include prompts. And what is very important is to look at the intent. I think the industry is pretty early in terms of evaluate what's the intent of the prompts. That can kind of involve, how do you detect malicious prompt injection, for example, right? So even if the user didn't do anything because agent have access to external data sources or different contexts provided by other agents, how do you evaluate that? So to record and trace those prompts is actually also very, very important, and trace the intents.
Thank you. Now that we have context, can we ask the panelists to remind us what companies they do and how they can help us? Say.
So the question is, how can we help to implement this, right?
Like, who are you? Where you come from? What do those products do?
So about our company. Yeah. I mean, like say, right? So we built the whole kind of big data ecosystem, which Spark, Delta Lake, Iceberg, Unity, catalogs, Gravitino, Polaris. So everything built on Rust, 10 times faster, 20 times cheaper than JVM-based Spark. And again, like Rust everywhere. And I think that's the lakehouse of the future. If you want to build AI agents, I think the elephant in the room is all the kind of agentic stuff is derivative use of the ground truth. We have the ground truth and we can feed you at the speed you can accept. So, come and kind of, we'll launch it soon, lakesale.com, check it out, sign up, try it, play with it, talk to me, talk to us. We have the CEO is Shihab, he's here. However, this year we have folks, right? Talk to us, and hopefully, we're very early. And if you play with sale, you're gonna be very happy. And then, in a few months and years, you will be very happy you were at the start of this journey.
And I represent Fivetran, where we can move data from anywhere to anywhere, including managed data lakes, Iceberg data lakes, Delta Lake, whatever. And then on the DBT side, everything from core all the way up to the managed semantic layers, which is really just the structured foundation for AI.
Thank you for your question. So I'm from a company called Datastrato, and we make an open source catalog called Apache Gravitino. It's an open source product, and I would say that we do several things which each taken individually may be things that you can find elsewhere, but taken as a whole across several different things makes the product quite unique. We're an open source product, which means you can go to GitHub today and download Apache Gravitino because it's an Apache-based project that's open source. We provide you the ability to create a catalog for Iceberg and to integrate other catalogs. And so if you happen to have a Hive Metastore and you want to create an Iceberg catalog, you can do so. And then you can integrate some Oracle that you've got on the side, some Postgres, a variety of other things, and you have a single place for all that data. And we provide a semantic layer on top of it so that you can get into really govern metrics and AI. So taken together, very unique package. And if that suits you in any way, I'd love to talk to you more.
Yeah. Come from the company called LiveRamp. So LiveRamp is a data company that provide identity and data collaboration. What does that really means to the audience is, if you are a CMO and want to spend millions of dollars to reach more people, how do you know that I have reached in the Instagram versus Facebook versus X.com? How do I know that I'm not targeting the same person? How do I broaden my reach? That's what my company do. So we work with those paid walled garden data partners and be able to let you access their data and combine your first-part data to do identity resolution and help the marketing people to reach more people, more audience.